Hello and welcome back to another video in the hardware topic. Now, up to this point we have looked at peripherals, internal components, storage, parts of the CPU, the central processing units, and have an understanding of address, control and data bus. So in this video, we start to put it all together and learn how the central processing unit is able to actually collect data or instructions from memory, work on that data and instructions to execute and to produce something, and then to go away and store it either within the CPU or back into memory. That whole process is known as the fetch and execute cycle, and in your work booklet there are 4 steps as to how that is done. Can I say right from the start, you need to be able to memorize everything about the fetch and execute cycle. So those are the 4 steps and the diagram underneath, which you should be able to draw from memory. So what I'm going to do to start with is to go through that information in your booklet and show you how it works on the whiteboard. Step 1 is the fetch the instruction. And as it says in your work booklet, it says the processor fetches the instruction from a memory address stored in a program counter and transfers the instructions via a data bus to an instruction register. So let me explain that. What we have here is RAM. And one of the memory areas, called AE00, holds an instruction which says add number by 1. Now, as you well know, what would be actually stored within this memory address would be a byte of code. You wouldn't actually have something written like that. But for clarity's sake, we're saying that there is an instruction or part of an instruction at this memory address. Within the CPU itself, there is the program counter. The program counter already has the address as to where this instruction is found. So what happens is the CPU will want this instruction. So the memory address is sent from the CPU along the address bus, which, as you well know, is one directional. It will go along the address bus and from there locate the address AE00. Contained within that address is the instruction add number by 1. That instruction is taken back into the CPU along the data bus, and it is put into the instruction register, which I'm going to call add 1. Once the instruction is put into the instruction register, the program counter is going to then go and add 1 to the next address. So it's going to point to the next memory location. Once the instruction is in the instruction register, that is the end of step 1, fetch the instruction. Step 2 is decode the instruction. And as it says in your work booklet, it says the processor decodes the instruction stored in the instruction register. Here the circuitry figures out what the instruction actually means. So it goes from the instruction register into the decoder. The decoder is a bunch of circuitry that basically decides what actually the instruction means. And you can get lots of different types of instructions. It could be instructions that obviously need to be carried out, such as adding, taking away, or things such as asking devices to go and do something in particular. In this case, the decoder has figured out that the instruction that has come into it is asking to add a number by 1. That leads us on to step 3, execute the instruction. It says the decoded instruction is executed. So what happens is we have a number up here in a register. That number is taken out and it's put into the arithmetic logic unit, and the instruction is put in here as well. And so you can see that a calculation is produced. Obviously the answer is 5. That will lead us on to step 4, and it says the results generated by the execute phase is stored in the memory and or is set to output. So the answer doesn't stay in the arithmetic logic unit. It is sent via an internal bus, either back into a registry, or it is sent from the memory data register back along the data bus and would be stored in a memory address set. Now, when you are looking at the fetch and execute cycle, you will need to know that step 1 and step 2 are given a group name. That group name is called I time, which is instruction time. Step 3 and 4 is called E time, which is execution time, or the execution phase. So please make sure that you are very clear that there are 4 steps in the fetch and execute cycle, that you are clear about what each one does, and as I've said earlier, make sure that you memorize what is said in your booklet, and have a good careful look at the diagram and make sure you have you're able to draw that from memory as well. Now, what I want to do is just go through it again in a little bit more detail, just so that you get it very clearly. So let's have a look at this. Right, let's have a look at that whiteboard again. What we have are some assumptions. First of all, that within a memory allotment or slot, that there is an instruction stored. We've called it C3 because we can call it hexadecimal, and it just represents binary code. We also make another assumption in order for a program to run, that the program counter is already pointing to the start of the program. So in this case, here's the start of the program at AE00. The program counter is pointing there already. And up in this register here, we have a value. The value is 0, but I've put an H there to indicate that obviously it would be bytes of information, and I'm representing this as not only a value, but also as hexadecimal as well. So what happens is this. To work the fetch and execute cycle, this memory address is put into the memory address register, which is essentially the contact the CPU has to the address bus. This address goes along the address bus. And ends up at memory. Now, we have here our control unit with a control bus lines as well. Where these control lines come in is that we have a small charge of electricity which goes from the control unit to memory, and this line, the CS line, essentially tells the chip, the memory, to turn on. The second line, which has R/W, is read-write. And this issues an instruction as where the information is going to be read from the memory or written to memory. In this case, the instruction is going to be to read from memory. So the AE00 memory address is located, and what is going to be read is the instruction. That instruction goes along the data bus and it will go into the memory data register, whereupon it is copied, and a copy goes into the instruction register. Once the instruction is in the instruction register, the program counter will go and point to the next instruction in the line. So in this case, it could be AE01, and that will be sent at the start of the next cycle. Once the instruction is in the instruction register, that is deemed the end of the fetch part of the fetch and execute. The instruction will go into the decoder, and the decoder will decide what needs to be done. In fact, the instruction is broken into two parts. One part is called the operand, and the operand is where the CPU will decide what type of calculation is needed, whether it be adding, taking away, multiplying, or whatever. The second part is essentially the data that goes with that operand. Once the decoder has decided what that instruction means, information from that instruction goes into the control unit. It's at this point that the control unit will take over, and it will call out from the register whatever the value is. So this will come out, and information from the decoder goes into the control unit. The control unit will, in this case, request that this value is increased by 1. The result, which will be is calculated, which is the execute part, and then from there the result is taken via an internal bus, either back to the register, or it would go through the memory data register and be written back into memory. Which would be where the store is. So what we have there is a little bit more of a detailed explanation of the fetch and execute cycle. Thank you very much for watching, and I will see you in the next video. Bye-bye.